Welcome to 4.2. If you have not seen the Purple Shirted Nerd unit circle video, highly recommend that before this. It shows how we can come up with all of these values at our 30 and 60 degree angles on a unit circle, talks about unit circle, and these 45 degree reference angles on a unit circle without memorizing much at all. So really highly recommend you take a look at that. Otherwise, some of what I do in here might slip past you. It's on the website as well. So this is a unit circle. Unit circle has radius 1. The quadrantal angles, they're called. The ordered pairs are a breeze to figure out. And there's really good reason, as you're going to see shortly, to know what all of these points along the unit circle are. Really helps out with our trigonometry and our speed, and if we can be all about being quick and efficient and accurate, boy, that's the full package right there. For the purposes of today's lesson, I'm not, or this video, I'm not going to talk about periodic function, even or odd trig functions, or circle with radiuses other than 1 that we lie on. But some of that's actually even discussed in the first video right here. So anyway, let's just get straight to it here. Here's why it's so beneficial. If we take a look at this angle right here, for instance, and we'll just say this one's theta right there, or t is they're using sine of t, cosine of t. If I asked you for sine and we knew that this was 1 right here, because it's a unit circle, I know that this distance is square root of 3 on 2 in this right triangle, and I know that this distance is 1/2. We can go back to SOHCAHTOA. SOHCAHTOA says sine is opposite on hypotenuse. It's 1/2 on 1. Oh, this is the sine of 30 degrees. This is the sine of 60 degrees. Cosine is adjacent square root of 3 on 2, all divided by 1. So when we have an R value of 1, the sine is just Y. Cosine is just the X value of the ordered pair. So if we know the ordered pairs, we've got a lot of sine and cosine functions at our disposal. Okay, first off then, on this problem, if you notice, this is 5/12. Oh, excuse me, the height is 5/12. Zoom in on this just a little bit. The height of this point is 5/12. If I draw in my right triangle here, over to here is 5/13, excuse me, 12/13 to get over here. This is a Pythagorean triple, 5, 12, 13, so this is 13/13. It is 1. This is a unit circle. Therefore, the sine is just the Y value. So the sine is the Y value. The sine is 5 on 13. We learned that cosecant is reciprocal of sine, so when I get sine, I've got cosecant. Highly recommend when you're writing these down for answers, you always put cosecant across from sine, since they're reciprocals. Cosine is the X value. The X value is 12 on 13. And unless these fractions, one of these fractions would simplify, these 13s are always going to be shared because this is the hypotenuse value. Okay, in this case it's rounded, it's like D simplified, but anyway, these are going to match, which makes finding tangent easy because tangent is y on x or sine on cosine. Sine on cosine. So it's this divided by this. The on 13s cancel and we get 5/12. The on 13, because it's 5 on 13 divided by 12 on 13, which of course we know is equal to 5 on 13 times 13 on 12 cancels. The on 13s cancel when we flip and multiply 5/12. So secant, reciprocal of cosine. Cotangent, reciprocal of tangent. We will talk why cosine isn't the reciprocal of sine. That would be a good question to ask now, and that we're going to talk about that later on in this chapter. And cotangent is 12/5. So once again on number 12, numerators only. We got a 3, 4, so it's negative 4 to get to here, so it's a length of 4. This is a length of 3, both of those on 5. So this must be 5 on 5. So this is a unit circle. And it's worth noting that the hypotenuse is always considered to be positive no matter where you are. But because we went left and down to get here, x and y are negative. So sine is the y value, negative 3/5, making cosecant negative 5/3. Cosine is the x value, negative 4/5, making secant negative 5/4. Tangent is this on this. The negatives cancel, the on 5s cancel, and we get 3/4, making cotangent 4/3. Simple. Okay, 14. This is warm-up for us here. This is warm-up so we can actually find trig values down below. We have to get the angles in the right spot. So I say this, when we're dealing in radians, until we're really comfortable with radians, we probably want to take a look at the denominator and say, well, it takes three tick marks to get me to a full pi. So that would be like 1 here, 2 here, 3 there, but we just want one of those tick marks. Pi on 3 gets us right there. It happens to be a 60-degree angle, and we would notate that saying we rotated that way. 4 tick marks gives me 180. 1, 2, 3, 4. Pi on 4, pi on 4, pi on 4, pi on 4. I need to go one more tick mark to get to 5/4 pi. So there we are halfway through quadrant 3, and our angle is that. T is just plain old pi. Don't need tick marks. Pi gets me right around to here. So our angle is here. 3 tick marks. I'm going backwards. I need 4 tick marks, but I need 3 to get me to 180 or negative pi. That would be 1, 2, 3. I need a 4th one. Takes me farther than halfway through the quadrant. There would be the 5th one back to the 6th one. So negative 1, 2, 3, 4 gets me here. And careful on this, if we just leave it as this angle, the reader might assume we're talking about that. But we're really talking about that angle. And number 22, tick marks of 3. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We get to here with 11 tick marks. Now, how do we illustrate to the user that it's really 11/3 and not just this angle or not just that angle? We spiral it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's our 11 right there. 11/3. Okay, but again, that's all warm-up for what we were doing before. So pi on 3, here's where we're going to use our unit circle information. This is why, once we get to this point, we're going to use these values, but I don't have those memorized. That goes back to the previous video that I just cannot speak strongly enough the need for you to take a look at that. So pi on 3, just 1/3. That's 1, 2, 3 tick marks to get there. We're talking about this. This is 60 degrees. This is the short of the 3 possibilities. The short to get over to it is 1/2. It is the tall of the possibilities. The tall is square root of 3 on 2, and that's discussed on the previous video. So if you're lost right now, you probably should be. You haven't seen the previous video, the unit circle. And now I know that sine is the y value, square root of 3 on 2. Cosine is the x value, 1 on 2. And tangent is y on x. The on 2's cancel, square root of 3 on 1. So maybe you need to stop this, go back, watch the other video. All right, tick marks takes 4. I need 4 to get around to negative pi, but I need 5 of them. So there's 1, 2, 3, 4. 5th one gets me right here. So there's a 30, there's a 45, there's a 60. This is my middle. I got to go over middle and up middle. over middle and up middle. The middle value is root 2 on 2. The up value is also root 2 on 2, but this was to the left. Sine, square root of 2 on 2. Cosine, negative square root of 2 on 2. Tangent, positive divided by negative, negative. Root 2 on 2, square root of 2 on 2 divided by square root of 2 on 2, 1. Maybe you can pick up on this without seeing the previous video as we're going through this long, short, middle discussion. Tick marks of 3, I need 5 of them. 1, 2, 3, 4, 5. We're right here. I'm at a location, you might want to do this, where I'm right, positive, and down, negative. It's short to get to here. Short is 1/2. It's long to get down here. Long is square root of 3 on 2, in this case negative. Sine of t is the y value, negative square root of 3 on 2. Cosine is the x, 1/2. Tangent is this divided by this. The on 2's cancel, negative 3 divided by 1, negative square root of 3, excuse me. That's it. 6 tick marks to get halfway around, but I need 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or we could say we're just one short of 12, 6, which is 2, just one back this way. So here's our angle right here that we get to. This is right and down, right and down. The negatives are the most frequently missed things doing this. It's long to get over to there, square root of 3 on 2. It's short to get down there, 1/2. Sine, the y value. Cosine, the x value. Tangent, this on this, which is negative 1 on square root of 3, which we should rationalize, times square root of 3 on square root of 3, we get negative square root of 3 on 3. 2 tick marks to get halfway around the circle. I'm going backwards. There's 1, 2, I need 3 of them. So we end up, our angle is really here, but it doesn't matter. We get to this point right here that is left 0, up 1. The quadrantals should be the easiest ones for us. Sine is the y value, 1. Cosine is the x value, 0. Tangent wants to be 1 divided by 0, but that is undefined. Awesome. So same thing now, except now we're going to add cosecant, secant, cotangent to it. 6 tick marks. To get halfway, I need 5 of those. 1, 2, 3, 4, 5, which means it's long to get over here. Square root of 3 on 2, but it's to the left. It's short to get up here, just 1/2. Sine is 1/2. Cosine, negative square root of 3 on 2. It's the x value. Tangent, this on this, which is 1 on negative root 3, or negative root 3 on 3. Cosecant, reciprocal of sine. Secant, reciprocal of cosine, which is negative 2 on square root of 3, or negative 2 square root of 3 on 3. Cotangent is reciprocal of this, but remember where this came, or cotangent, reciprocal of this, remember where this came from. Tangent was 1 on negative square root of 3. If I flip that, I just get negative square root of 3. Think maybe you can really appreciate, especially since many of you have already worked with this kind of trigonometry before. I think this should be an eye-opener for you. Takes 2 tick marks to get halfway, but I want 3 of them. 1, 2, 3. We're right here. These are the easiest ones. I'm to the right, left, 0, but I'm down 1. Sine, negative 1. Cosine, 0. Tangent, negative 1 on 0, undefined. Reciprocal of negative 1. Reciprocal of 0, undefined. Reciprocal of undefined, 0. 4 tick marks to get halfway. 1, 2, 3, 4. But I need 7. 5, 6, 7. So now I'm between the 30 and the 60. This is middle to get over to. Root 2 on 2. It's middle to get down to. Negative root 2 on 2. Excuse me if I say root, not square root. Sorry about that. It's implied square root. So the y value, negative square root of 2 on 2. The x value, square root of 2 on 2. This on this, the on 2's cancel, the square root of 2's cancel. Negative divided by positive, negative 1. Reciprocal of negative 1, negative 1. Reciprocal of this is negative 2 on square root of 2. If we rationalize, we end up with, I'm going to jot this down here. Just wanted to show you this once. Negative 2 times square root of 2 on 2. Those cancel. This is just plain old negative square root of 2. Reciprocal of this is then, by the same rationale or same algebra, same computation, same rationalization of denominators, is plain old square root of 2. All right, I'm going to go through these last 3 problems with you. It's no different. It's just that we might spin around the circle more than once. 1 tick mark gets me halfway. I need 5. 1, 2, 3, 4, 5. We end up back here. So there's our angle. This is the point negative 1, 0. We are only to find cosine of that. So cosine of 5 pi is the x value, negative 1. Wow, that's awesome. Fourths, 1, 2, 3, 4, 5, 6, 7, 8, 9, halfway through. That's between the 30 and the 60, so it's middle to get over there. Square root of 2 on 2. It's middle to get up to there. Square root of 2 on 2. So the sine of 9/4 pi is the y value, square root of 2 on 2. 6 tick marks. 19. Now, by this time, we might be saying, well, 12/6 gets us all the way around backwards. I need another 7/6, but we could always do this. 6 tick marks. 1, 2, 3, 4, 5, 6 gets me there. I need 19 of them. 6, 7, 8, 9, 10, 11, 12. So now it comes down to just 7 more here. 13, 14, 15, 16, 17, 18, 19. We end up there. So you might want to think of this as just, well, this is sine of negative 12/6 pi minus 7/6 pi. I don't really need to worry about that because that just gets me back to the starting point. That's what they're saying with use its period as an aid. So anyway, we still end up in the same spot. That is, I'm going to put this point up here. That's long and left to get to. That's a 30, or 45 and 60 would be here and here. Long and left, negative root 3 on 2, but short, 1/2. We want sine of negative 19/6 pi. That's the y value. It is positive 1/2. So cosine, 1, 2, 3, 4, 5, 6, 7, 8. But we might have just said, well, 6/3 gets us all the way back to the starting point. Just negative 2/3 more gets us to here. That's the big angle. That's the big reference angle, 60 degrees here. So it's short to get over here to the left and down long. See, here's the 45, here's the 30, here's the 60-degree reference angle. Down long, negative root 3 on 2. So cosine of negative 8 pi on 3 is the x value, negative 1/2. And that's where I want to stop on this video. We'll just have a very short amount of this to pick up, and that will be on the following video, the backup to this. So hope that makes sense. That is just, I can't begin to tell you how important that can be for you moving on, not for accuracy alone. There's other ways to do it for accuracy, but just for speed, convenience, and accuracy. When we can combine those things, it's pretty special.